Good morning to all. Today we are going to discuss about basic interactions of X-rays with matter. Myself D. Sivakumar, Assistant Professor and Head Department of Medical Physics, Dr. N.G.P. Arts and Science College, Coimbatore. In this video, we are going to see about coherent scattering, photoelectric effect, Compton effect, pair production, photo disintegration. These five interactions are happening by X-rays when it interacts with matter. This slide illustrates electromagnetic spectrum. Electromagnetic spectrum consisting of ionizing and non-ionizing radiations. Ionizing radiations are X-rays and gamma rays. It has a higher energy and a smaller wavelength. Non-ionizing radiations having longer wavelength and small energy, and it has some properties, some characteristics. It can travel at the speed of light, and it has dual nature, and it has a direct relationship with frequency and indirect relationship with wavelength. T is equal to h nu, nu is equal to c by lambda, E is equal to h c by lambda. That means wavelength is more, energy will be less. Frequency is more, energy is more. That means energy and frequency are direct relationship, and lambda, wavelength and energy are indirect relationship. Introduction. When photons interact with matter, the photon energy fully absorbed or scattered. There are five major types of interactions may occur. First one is coherent scattering, second one is photoelectric effect, third one is Compton effect, fourth one is pair production, fifth one is photo disintegration. When photon interacts with orbital electron or nuclei, the energy of the X-rays is fully absorbed or scattered. When scattered in random direction, it will create a noise. Because of this noise, the film quality will be decreased. Because of this lower image quality of the radiographic image, we cannot get required information of the patient. When photons interact with matter, there is no change in wavelength but change in direction. It is called coherent scattering. Coherent scattering are two types, Thomson scattering and Rayleigh scattering. These both are also called classical scattering. Both are wave particle interaction. There is no ionization occurs because of no energy is transferred from photons to human body. Very small percentage of radiation undergoes this coherent scattering. It is less than 5%. Because of this less than 5%, there is no significant scatter radiation. Also, it produces small scatter radiation to film fog. During the Rayleigh scattering event, the electric field of the incident photons, electromagnetic wave, expends energy, causing all of the electrons in the scattering atom to oscillate at the same frequency. The X-ray photon is scattered through small angle without change of X-ray energy or loss of energy to the medium. It is the scattered photons has the same energy as the incident photon. This interaction mainly occurs with very low energy of X-rays. It is 15 to 30 keV. In these interactions, electrons are not ejected and thus ionization does not occur. Photoelectric effect mainly occurs with tightly bound K-cell electrons. When the incident photon interact with K-cell electrons, its all of the energy is transferred to an electron which is ejected from the atom. After ejection of the electron, the neutral atom becomes positively charged ion with a vacancy in an inner shell that must be filled with a nearby less tightly bound electron. It may be a L cell electron or M cell electron. The kinetic energy of the ejected photoelectron is equal to the incident photon energy minus the binding energy of the orbital electron which is ejected from that respective orbital. In order for photoelectric absorption to occur, the incident photon energy should be greater than or equal to the binding energy of the electron that is ejected from the orbital. This slide illustrates photoelectric effect. You can see here incident photon interact with KCl orbital electron. This orbital electron is ejected from the atom. In next picture you can see there is a vacancy. To fill the vacancy, the less tightly bound electron comes to fill here. When comes to here, the binding energy of the two orbital electrons will be emitted as characteristic X-rays. The end product of photoelectric effects are photoelectron, characteristic X-rays and a positive ion. These positive ions occur because of electron ejecting from the atom. The photoelectric effect is predominant for low energy photons but higher than binding energy of the electrons. When the material having higher atomic number, then photoelectric effect will be more. So the probability is proportional to Z cube and inversely proportional to E cube. That means energy is increasing, the photoelectric absorption will be less. While atomic number is increasing, then photoelectric effect will be more. Compton scattering is the predominant interaction of X-ray with soft tissue in the energy range approximately from 30 keV to 24 MeV. This interaction is most likely to occur between photons and the outer shell of electrons. The electrons is ejected from the atom and the photon is scattered with some reduction in its energy. The energy of the incident photon is equal to the sum of the energy of the scattered photon and the kinetic energy of the ejected electron. The binding energy of the electron that was ejected is very small. This slide illustrates Compton scattering. When incident photon interact with loosely bound electron, the electron will be ejected. That electron is called recoil electron or scattered electron. Its kinetic energy is taken from part of the incident photon energy, and the incident photon deflected at a small angle and retain the energy that is called scattered photon. The scattered photon energy is depending upon the incident photon energy and the angle of deflection. In diagnostic radiology, all the scatter radiations comes from only Compton scattering. This Compton scatter is no useful in diagnostic radiology because it will give noise to the film. Because of this noise, the image quality will be reduced. Pair protection. Pair protection is not much important in diagnostic radiology because we are using X-rays in the diagnostic range. The pair protection may occur only the energy of X-rays is equal to or more than 1.02 MeV. If the X-ray energy is less than 1.02 MeV, the pair protection will not occur. It cannot happen. When the photon interacts with the electric field of nucleus, its energy is fully transferred or converted into positron and electron. The positron and the electron having equal energy of 0.511 MeV. Suppose the photon energy is more than 1.02 MeV, that energy will be converted into kinetic energy of the positron and electron. These electron and positron are highly reactive particles. After some time, it will lose its kinetic energy via excitation. After that, it will recombine and produce two photons in opposite direction with energy of 0.511 MeV. These annihilation radiation, that means that photons will be useful for diagnostic imaging in PET-CT machine. Pair production becomes more likely with increasing atomic number and increasing photon energy. Pair production has no importance in diagnostic radiology. Photo disintegration. Photo disintegration occurs only the energy of the photon is more than 7 MeV. Suppose it has less than 7 MeV, the photo disintegration does not occur. When photo disintegration occurs, part of the nucleus of an atom is ejected by a high energy photon. This ejected part of the nucleus may be a neutron, a proton, an alpha particle, or cluster of particles. The photons must have sufficient energy to overcome nuclear binding energies of the order of 7 MeV to 15 MeV. Relative importance of photon interaction for soft tissues. Photoelectric depth is the predominant interaction for beams below about 30 keV. Compton is predominant interaction for beams above 30 keV and below 24 MeV. Pair production becomes the predominant interaction above 24 keV. Summary. The attenuation is the reduction of intensity of an X-ray beam when it travels matter. The attenuation of monochromatic is exponential. That means each layer of the absorber attenuates the same percentage of photons remaining in the beam. But the attenuation of polychromatic radiation are not exponential. Low energy photon is attenuated by the first few centimeters so that the quality of the beam increases as passes through the absorber. The amount of attenuation depends on the energy of the incident radiation and atomic number of the absorbing material and absorber density and electron density. Electron density means electrons per gram. Increasing the radiation energy increases the transmitted photons. That means the absorption will be less, but increasing the atomic number and absorber density and electron density decreases the transmission. That means the attenuation will be more. The radiographic image contrast is largely depends on electron density of the tissue. The contrast between air and soft tissues occurs entirely because of density difference of the absorbing material. Thank you.